Welcome back to this channel. So in the first video, which was the part 1, we have seen the Python data types, which contains numeric data type, sequence data type, mapping data type, Boolean data type, and set data type. In this video, we will see the binary data types in detail, like bytes, ByteArray, Memoryview are the binary data types in Python. So let's see. If you haven't connected me on LinkedIn, so you can connect me on LinkedIn. I will provide the link in description. First, we will see what is the use of binary data types in Python, why these data types are there in Python, or what is the use of these data types in Python. So let's see. So first of all, binary data is compact as compared to text-based representation. So that's why most of the things are possible with the binary data type as compared to other data types in Python. Binary data type is used in file input-output networking protocols like HTTP, FTP, and databases. So mainly, binary data types are used for files to store, execute files like images, audio, video files. These files are stored in binary format. Then it's also used in cryptography and security. And binary data is also helpful in communication, like serial communication with the USB, Bluetooth, which we used nowadays. So let's see when to use which binary data type. Binary data type contains 3 data types like bytes, byte array, and memory view. The difference between bytes and byte array is bytes are immutable, which cannot be altered or modified. That's why the bytes can be used in hashing and file handling. And byte array can be altered, modified. So it can be used in stream processing, input output buffers. Memory view is mostly used for database optimization because of the efficient handling of large binary data is possible with the memory view. Now let's see the corresponding binary data uses and the working in Python. As we seen earlier, binary data type provides bytes, byte array, and memory view. These 3 data types to serve different purpose, and these 3 data types have different purpose, different use cases, and we have seen those use cases just now. The first is bytes. The bytes data type in Python is a immutable sequence of single bytes. Each byte is an integer in the range of 0 to 255. And bytes are often used to handle binary data like reading, writing files, working with network protocols, as we seen earlier. Byte objects can be created using bytes function. So first of all, I will provide the size 5 to the bytes function to create an empty byte array of the size 5. And we will see how our first byte object looks like. You can see it created the empty array of byte array size 5. Next is providing actual data to the bytes. These numbers represents the binary representation of alphabets. So we are providing these as a byte array or array in array format to create the byte object. And we will see how our byte object, which is non-empty, looks like. It's binary representation of hello. So there are multiple types of encoding available like UTF, ASCII. So we can provide the encoding to the object. So like I have provided the encoding UTF-8 to the object hello, and let's see how it looks like. It again gave us the hello in the binary. Now accessing bytes or the data in the bytes. So for example, let's print B1 first, which is the empty array or empty byte array with the size of 5, and B2. So let's print B2 first to see what the B2 looks like. So yeah, B2 is hello in the binary format. Let's try to access the first index of the binary data stored in the B2 object. It's 104. That is the binary representation of character H. Now I want to modify the byte object B2 and I want to change the first character to the 100. And let's see if it works or not. You can see it gives error. And this is because bytes are not mutable, or it cannot be altered or modified once created. Same like an array or list, we can iterate through bytes. So let's see. We are iterating here through the byte object B3 which we created, and you can see it gave us the binary representation of each character. So you can use the different encoding as per your requirement. For most of the characters, the output will be the same. For some special characters, output may be changed as per the encoding which is used. So I have created apple and storing apple string to the binary format in the variable b, and I'm using UTF-8. So we can use ASCII encoding here as well, which will give the binary format in ASCII. And you can use custom encoding as well, like UTF-16 I want to use here. Let's see. You can see it gave the UTF-16 binary format. Next is byte array. The byte array in Python represents mutable sequence of bytes, which is unlike the bytes data type. Similar to the bytes, byte array also holds the range 0 to 255, which is similar to bytes object, but the one difference is that the byte array can be modified. And this mutability makes byte array useful for the task which involves binary data manipulation, like file input output operations, network communication, and working with the low level data. We used byte array function to create empty byte array. And let's see how it looks like. You can see byte array, binary representation of empty array, which we have created. Let's try to give size. You can see it created an empty array with the byte array of size 5. You can also give any size you want if you want to create an empty byte array. Let's initialize byte array with the binary data as an input, that is binary hello. And let's print it again. You can see it's more similar like bytes, but it contains byte array as a function, which represents that this binary data can be altered. We can provide the array of binary data, which we have seen earlier in the bytes data type, and we try to print it so that we can see the output. You can see it's printed as binary ABC. Now, unlike the bytes, we can modify byte array. So let's try to see what is the value at the 0th index first. Then after we will try to modify it. So 0th index, that is first value, is 65. We will set it to 68 and we'll print it again. And you can see after changing first position data to 68, we have got it as a 68. All the functions which are useful to modify or alter the data can be applicable here in the byte array as well. Most of the functions are similar to the list, and working is also similar to the list. For example, we can append single element to this binary array, that is byte array, and let's print the contents of the array. You can see it was first A, B, C, then we modified it to 68, that is D, so it became DBC. Then we append 69 and it became DBCE. Now, if you want to add array into the byte array, then you use extend function instead of append if you want to add multiple elements in the byte array. If I add this, and then let's print the contents of array or byte array again, you can see two more characters F and G added to the existing byte array object. Same like the adding or append and extend, we can delete the element from byte array objects as well. So here we are using first index, that is second number object will be deleted from this byte array. Let's see. And let's print the array again to see the existing contents. You can see here the element which was at the number first, that is at the index first, that is at the second number position, that is B, is deleted. If you want to delete complete binary object, then you can do that as well. So for example, I am creating another binary byte array object with the size of 10, and let's print it. Let's create it. Let's print it to see the output, like we can see here. And now I want to delete the complete binary object. This will delete. Now again I try to print after deletion of binary object. It will give error because the object is not exist. Now byte array have another set of functions or methods which are used to search or check the check for the data in the binary byte array. So if I want to find the array of byte array to find any object or item, I can find it. And as it is returning 1, that is the object 67 is there. Let's see the type. What type of data is gives as an input. We need to print it as well. Okay, so it gives output in the integer format as the output is integer class. Also use replace function to replace the existing sequence. Let's try to replace fg. This is the current byte array looks like, and we will replace fg sequence with xy sequence, and we'll print after it. You can see dxy xy, that is fg is that is sequence fg is replaced with xy. We can also use reverse function to reverse the contents of byte array. So as you can see, the existing byte array looks like this. After using the reverse function on the same byte array, what we can see is the contents of the array which was previously there are printed with the reversal format. So you can see here the contents are reversed, that is gf by xd. Why the gf came into the picture? It should not be there, as we have replaced the contents of array, that is sequence fg with xy. So it should be print with the values or sequence like yx, yxd. But why this happened? Let me tell you. So when we used replace function, it just gave us the output, but we have not stored that output in the array again. So to do so, should have used like this. Then only it will store the replace result in the array object or byte array object, right? So be careful while using replace function, because replace function needs the variable to store or the object to store the output, right? So let's jump to the next binary data type, that is memory view. As I said earlier, the memory view data type, which is binary data type in Python, is very useful for optimization. Why? Because it provides the view into existing data rather than creating a new copy of it. So memory view objects can be used or can be created using the memory view constructor, and which takes the object as an input or as a argument, which supports the buffer protocol. That is, memory view takes the binary objects or binary data, that is byte array and bytes, as an argument to create the memory view objects. Memory view object offers functionalities like slicing, indexing, typecasting, which is very similar to the other sequence type like what we seen in the strings. And modifications made through memory view objects directly affect the original objects. So let's create a byte array, the byte array function or constructor, and stored it into the data variable or the variable called data. And now we can create the memory view object using the byte array or byte type of data. So view variable contain the memory view object. And now let's try to print both binary object and memory view object. So you can see hello world, that which is the byte array, is having the memory object which is look like this, that is the memory at this particular location. So it will give the location. We can access and modify the data through the memory view like the other sequence type of objects. Like so, for example, view 0 to 5th, that means the first 4 characters are should be updated. We can access the memory view objects same like a list or array. Let's print it. You can see it gives us the location, and if we try to modify it, we cannot assign the memory view object to the binary or byte object. So this is the bytes object which we are trying to assign to the memory view object. So we need to first create it into the memory view data type or object, and then we can able to assign it. So this we need to take care of while using the binary data or binary data types in Python programming. So why this error is happen even after we creating the memory view object to replace the some of the values of memory view object. If you see carefully, we have created bytes into memory view, and bytes are immutable. So assigning the or modification in memory view object needs mutable. This cannot be done with the bytes. So let's try to create bytes into byte array first, and then we'll create it into memory view, and then we will create the memory view object out of it, and then we will try to assign it to the some of the memory location. Now again, even after creating the byte array, which is mutable into the memory view object, we are getting the error. So as you can see in the error message, L value and R value have different structures. So if we see the length of this object, which is 1, 2, 3, 4, 5, 6, and the difference between the 7th location and 12th location, or the 7th position and 12th position is 5, which is not uh, which is not making the left hand and right hand sides as the same. So we'll try to replace with the 13, which so that we can get the exact size on the both side. And now you can see there is no error. And yeah, we try to print data first. You can see it's printing hello Python instead of hello world. Its memory view data type created it easy and convenient to correctly or exactly modify the data from the original location itself. So in this video, we have seen the binary data type objects or binary data in Python in detail and their corresponding use case. We can use bytes for fixed binary data like network packets, file contents. But when it comes to the modification or alterable conditions, that is the real-time data processing, we can use the sequence of binary data, which is modifiable, that is ByteArray. And when it comes to the performance critical applications and the optimization part, like database optimization, then we will use memory view data type instead of other byte array object, which will avoid the redundant copies, and it will directly modify the object or the value from the original location itself. So this was about the detailed detailed this was about the so in this video we have seen the detailed part in the Python binary data so that we can get the idea. Unlike the usually used data types in Python, we can also aware of these binary types or binary data types so that if we need to okay, like and share, subscribe to this channel. So please like, share, subscribe to this channel so that I can get motivated to create them videos like this. Please like, share, and subscribe this channel so that I can get motivated to make videos like this. Thank you.